Hello and welcome to this ABAP language course. ABAP is the Advanced Business Application Programming language brought to you by SAP. We're going to head into our Eclipse IDE with ABAP Development Tools. If you do not have Eclipse or the ABAP Development Tools, also known as ADT, please check the link under this video and get yourself set up. Now that we're in Eclipse, we'll head over to the Project Explorer and look at our new ABAP Cloud project. I have one made right here. Go up to File, New, ABAP Package. We're going to name this zpack_ABAP lang_55. The description could be ABAP language course. Add this to your favorites to make it easy to find. We can leave it without a super package and with the package type of development. Click Next. We need a software component. We'll use zlocal. You can see for me, I have that right there. Click Next. Next, we need a transport request. I have an ABAP lang transport request already made. If you'd like to make one, click New Request, type in ABAP lang, and click Finish. I'm going to choose my ABAP lang and click Finish. It's time to make our first class and say hello to the world. So we'll head to our zpack ABAP lang 55, right-click on it, click New ABAP Class. This class can be called ZCL_types_55. Types class. We don't need a superclass, but we will use an interface. The interface we want is IFOO_ADT, and here we are, class run. So just click OK on that. You'll see it here. Click Next. Assign it to the same transport request as last time. Click Finish. Now we have our class definition and our class implementation. We also have the interface we brought in and a method from that interface called main. That's where we'll be doing our code writing. You could take a look to the left here under classes. You should just have types. You can ignore the rest of these. These are future lessons. So let's go ahead and say hello to the world. We'll outwrite with a pointer in between, single quotes, hello world. Period after that. Save it and then activate it, which you could do right up here by clicking this. And you can run it by clicking this button here, but I'd like to use the hotkeys. So if you're on a PC, hit Control F3 to activate. If you're on a Mac, hit Command F3 to activate. After you've activated, you can run with button F9. And we see hello world. Let's talk about comments. This is how you do a comment. So double quotes and everything after it will be commented out. The other way to do it is at the beginning of the line to put up an asterisk. An asterisk, a star, the all symbol for your SQL guys, but it has to be at the beginning of the line. If it's anywhere but the beginning of the line, it won't work as a comment. Let's jump into individual data types. We'll write that here, individual data types. And we'll use data objects to see some of these types defined. So we'll say data, we'll call this one char, and the type of it is C for character, and the length of it, let's just give it 1. Then we'll have a value of single quotes, C. So we made a data object called char, which is a character of length 1, and it's holding the value C. Let's do a few more of these. Let's do a string data. So we'll write str type string. It doesn't need a length because strings are fixed length, so we don't need to set the length, but we could set the value here. And to do that, open up backticks. And with those backticks, we'll write I am a string. And instead of a period here, just comma, and we could do another data declaration where we'll do, how about num? And that'll be type N for number, we'll give it a length of 3 and a value of 102. And hit the period there. Let's outwrite this and see what it looks like. So we'll outwrite a few times here. I'll just copy and paste it. And here we are. So first we'll outwrite the char, then the string, then the num. And we can save and hit Shift F1. It'll organize our code for us. And then we'll activate and we'll run the code. We see what we put in there. We had C, I am a string, and 102. Let's take a look at the other data types. So we'll write data and we'll go through a few more of these. First we'll do integ. That'll be of type I for integer, and it'll have a value of 3. Now you could see this is fixed length as well because we didn't have to give it any sort of length. Next we'll do flow, F-L-O. That will be type F for floating point number. I'm going to give it a value of 3210. Name the next one pack. The type will be P for packed number. This needs a length. I'll give it a length of 5. And it also needs decimals. How many decimal places will it have? Let's say 2. And then we'll give it a value, but we'll wrap it in single quotes. So we could say something like 1, 2, 3, 4, 5, 0.99. Name the next one time. It'll be type T for time. It doesn't need a length. This one is fixed length. We'll give it a value and wrap it in single quotes. How about 12, 30, and 11 seconds? And finally, we'll do date. Give that a type of D for date, a value, also a fixed length here. We'll give it, how about 2030, 1231. So 2030, December 31st, New Year's Eve. Now I'd like to outright all of these, but I'd like a little more structure. So we're going to make a structure to hold all of these data objects, or at least their values. So let's get that started. We'll come over here and we'll write down types. Now we're going to begin a type. So begin of, and let's call it ABAP underscore types. And then we comma and we start making our structure. Inside of here, I'd like to copy what's going on up here. So we'll say integ type I, and we're no longer defining values, we're defining a type. So we're just giving the structure and none of the values. So we'll do flow type F, pack type P, length 5, decimals 2. And we have time type T, and finally date type D, comma to the end of this, and then we'll write end of, and then ABAP underscore types. Now we have this user-defined structure, the structure that we defined, and we're ready to use it. So let's write data, and we'll name this ABAP types underscore struct. And for the type of this, it's the type we just wrote, ABAP types. Well, we could put that right there. Now with this type, we can go ahead and write it out again. So ABAP types struct, and then we could point to each one of its elements. You can see we have integ, flow, pack, time, date. Let's do integ. So integ is going to equal the integ up here, so integ. And I'm just going to do this for everything. So I'll copy this and we'll do this over and over. We need 1, 2, 3, 4 more. Next one is flow, then pack, then time, and finally date. Great. Now Shift F1 to get this code looking much better. Save it, and under this we will outwrite our structure. So outwrite your ABAP types struct, save, activate. You might want to come down to your console and just clear it. If you just right click and clear, you can clear it. and then we will run. And we see what we have here. First, we have the integer, and the integer is 3. It looks exactly like we would expect. Then we have a floating point, and that's written in a different notation, but it should still be the same value. So this with 10 to the 3 here would be 3, 2, 1, and 0. We have our packed number. We could see we have exactly what we wrote in there. Our time comes out in the time format. Our date has those dashes to them. Let's take a look at ABAP types. Here you'll see we have data types, and those are all the ones that we use. We didn't use the hexadecimal field. Of course we could, and we didn't use the X string, which is a hexadecimal field of variable length. But we did use every single other one of these. And you can see what we were mentioning before. If it has only a single valid size, like 8 here, this is a fixed length. So date, time, integer, and float are all fixed length, and then string is also considered fixed length because we don't have to give it any sort of size at all. The rest of them are variable length, including character, number, hexadecimal field, and packed number. So let's get back into it. Now, we don't always have to write data in this way. I will go ahead and comment this out. Here's another way to define data objects. So we can data, open up our parentheses. Let's write char underscore type equals single quotes char. So we're asking the data object to infer the type by what we're assigning to it. Let's do it one more time with str underscore type for string type equals, and we could do backticks here, but this time I'd like to do our string literal. This allows us to do string interpolation, and anything we write inside of here is going to be of type string. So let's go ahead and write I am another string. Another thing we can do is use data objects within these pipes. So I'll open up some curly braces and use a data object right here. I'll use char type. So this should say I am another string char. And we're not only going to outright here, we're actually going to take a look at each of these types. So we'll outright, and we'll just write string type in here. And we'll start setting up some breaking points for our ABAP debug. So here's our breakpoint number 1. Oh, we have to save first. Breakpoint number 1 will be right there, and breakpoint number 2 will be right here. Okay, great. Now I like to right-click those and then go to refresh breakpoint activation. That's always good to do. Sometimes the breakpoints get shut off. So if you do that, you know that you're on and we're going to break at the breakpoints. Now, we are in the ABAP perspective right here. We're going to wind up in the debug perspective. If you want to get back to the ABAP perspective, you just click it right up here. So let's take a look at what happens at our breakpoints. We will save, activate, and run. And we'll head into debug. We could see we're at our first breakpoint in the debug. Now if we click on a data object, it will tell us a lot about it. We could see that char type is value char, and its type is C, which is a character type and has a length of 4, which is how many characters we actually assigned to it. So it was able to infer its type from what we gave it. At this point, we can take a look at string type, but it shouldn't be assigned yet. We're actually stopped at the line that is going to assign this value into this data object. So we do see that we have the string type and no value yet. We can use our debug tools to move to the next breakpoint, and this should be assigned. Go up here to the top left, you'll see a resume button. You could either click it or hit F8, and there's also the stop button if you want to terminate this debug. So go ahead and resume. It goes to the next spot, and you could already see now we have this assigned. I am another string, and then the word char after it, because we were able to use our string interpolation to get to this data object and put it in this string. So I'll let this finish up. There we are, we're all done there. Now if we want to exit the debug, we'll just go up to the top right and go back to the ABAP perspective. And we can also get rid of our breakpoints. Just double click them and they go away. Let's comment this out and talk about table types. We'll go down, right, table types, and we'll get working on that. In order to create a table, we'll want to first create a types, which will be a structure. So begin of, let's call it ID and name. It'll just hold ID, type I, and name, type C. It'll need a length. Let's give it a length of 20 for the name. And that's it for ID and name, so end of ID and name. So now we have our type made ID and name. Let's turn it into a table. And I could write types right here, but also we can comma to the next type. So let's comma to the next type for this one, and we'll call it ID and name underscore tab. And that'll be type table, well, table of ID and name, so table of that structure. And we're going to say with empty key. We won't get too deep into keys right now, but we will in the future. Right now, empty key should be real easy for us to work with. Let's head down and make our data object, which will be the table now. So data, let's call it the print tab, because we'll print this table out a bit. And the type will be the type we just made, the ID and name tab. And put a period after that. How do we populate this table? So in order to populate it, what we'll do is we'll get print underscore tab, set it equal to keyword value. After that, put a hash and open up some parentheses. The first parentheses are the entire table. Now the second parentheses I open here is a table row. So we'll have a table row with an ID equal to 1 and a name equal to Santo. And let's make another table row after it with an ID equal to 2 and a name equal to Katie. You could put a period after this, and I'd like this to look a little more like a table. Yeah, that looks a little better. This is basically what it will look like. We'll have ID and name, ID and name. These are the rows that we just put in our print tab with this value statement. Let's outwrite this. So out pointer right print underscore tab. Put a period after, save, activate. I'll clean this up a little bit. Clear. If you want to clear, it's always right click and clear, and run. And we see we have a table of ID and name. ID 1 is Santo, ID 2 is Katie. Let's comment this out, and we'll move on from there. Now I want to insert the table. So let's write inserting, internal table. We want to make a data object that is a row of the table. And we know we have a row of the table right here in ID and name. So let's write data. We'll call it IDN, and it can be type ID and name. Now we'll access its elements and populate them. So we'll write IDN and then a dash. And we'll see what we can populate. First is ID. Let's assign that 3. And we'll do it again for name. Let's assign that Tracy. Now we have this structure finished, this new table row, and we'd like to insert it into the table. The keyword is insert, and then what we want to insert, so the structure we want to insert, which is IDN, into table, and then the table name. So print underscore tab. Put a period after that, and let's take a look at that table again. We'll outwrite it. Oh, save, activate, and run. And we see now we have Santo, Katie, and Tracy. Now I want to use this data object again, this IDN. So what I'll do is clear IDN, and that will clear everything out of what's in that data object already, which is the 3 and Tracy. Let's take a look at that quickly. I'll just outwrite before and after there. We'll save, activate. I'll get rid of this. And we can run. And we see before it, it has ID 3 and Tracy like we assigned, and after it, it has ID 0 and name. And that is actually what should be there. If we look at our sheet here, we have numbers actually integers will start with an initial value of 0. So that 0 is there as an initial value. There is no empty for these integers. Let's comment this all out now. And we'll populate the IDN again, but this time we will append an internal table. And there are some rules for appending that we'll get into in a future lesson, but for now we have an empty key in this table and we don't have to worry too much about how append is working. We can just append to the table. So let's populate IDN again, IDN dash ID. Let's make that equal 4. And then IDN dash name, we'll make that equal flimflam. And let's append this one. So the keyword is append. And then what we want to append, which is the IDN to, and then the table we want to append it to. Let me write that all capitals. That is the print underscore tab. And let's outwrite the print tab after the append. Save, activate. I'll clear the console and we'll run. The activation didn't go through yet. I'll clear the console again and we'll run. Terrific. All right, now we have 1, 2, 3, 4. Everyone's been inserted into that table. The first one was an insert. The second one was an append. And in these videos, I know I'm throwing a lot of information at you just right away, but we'll keep doing this throughout the course. So if you feel like you're falling behind, we will keep on defining data, we'll keep on defining structures, we will keep inserting tables and so on throughout this course. So just keep on moving forward and it'll become a little more comfortable. We've gone through all the types I wanted to cover in this video, but I do want to talk about conversion quickly. So conversion. First, we'll make some data objects. We'll do data str underscore data. We'll do a type string and a value of backticks hello. And then we'll do a char underscore data type c length 3, and it doesn't need a value yet. First, we'll talk about implicit conversion. Implicit conversion. So if we are now to take char data and assign string data to it, what will we get? We will not get an error. Even though the characters only have a length of 3, we won't get an error for the loss of characters. We're just going to lose those characters. So let's outwrite what we get here. We'll save, activate. I'll get rid of this and we'll run. Okay, what we got was HEL, and I do have another print here. I see print tab. What we got is HEL, so we got the first 3 letters and we lost the other 2. So ABAP knows the data type it's being assigned to and does its best to convert it implicitly. Now, if we did an explicit conversion, it would look like this. We'll need a types. We'll call it 3 underscore char. Type C length 3. We made a new type there. That's a character of length 3. Now we'll outwrite, so we'll just do this directly in line here. CONV is the keyword. That's for conversion. Now the type that we want to convert to, 3 char, and what we want to convert, which is the str data, the string data. Put a period there. We'll save, activate. Actually, let's get rid of this outright here. So I'll activate again. I'll clear this out. And we should get the same result of HEL. So we have the same result, but we actually did an explicit conversion to a character of length 3. We are just getting started. There's a lot more ABAP to do. You should like and subscribe to this channel so these videos can be a resource for you moving forward. And if anything changes with ABAP, you'll get an update updating you on new ABAP features. There's a lot more to do, so let's keep coding. Now let's take a look at ABAP conditionals. Let's make a new class. We'll go to our classes, we'll right-click. Oh, this might happen to you. When this happens, you want to open your login page in your browser, and you'll be successfully logged in. So right-click your classes, new ABAP class, and let's call this ZCL underscore conditionals, and I'm going to name this 55 to keep with everything we've been doing. And we'll call it Conditionals Lesson. Add that same interface, the class run interface, so we could write out. Click Next. Grab the transport request we've been using and click Finish. Now we could see what we saw last time. We have our class definition and our class implementation, and of course our main out here in this method, so we could write our outs. The first thing we'll do is the if-else. So let's make a comment here and say if-else statements. Here's how an if-else statement works. We'll use our data like we did last time, and we'll define it in line. Let's call this str1, so string 1 will equal, let's put our pipes up, and let's say ABC. Period after that. Let's make another data object. We'll call it string 2, and that will equal also ABC. Now we'll say if, let's do this capital, if str1 is equal to str underscore 2, and I should have put an underscore here, we'll put a period there. Now we write what happens in this if statement. We'll write equal. Let's head to the else of this. Else, and we don't need to do an else here, but we will. With the else, we'll period and we'll write not equal. And at the end of this, we have to end the statement with end if. Now we can see how our data evaluates here. Let's save this. Let's go ahead and activate. We've activated, and we'll hit F9 to view in the console what comes out. Equal. So these two are equal right now. Let's change this to ABD, save, activate, run again, and we get not equal. So this is how a basic if-else statement looks, and this is how it works. Let's get rid of this for now and keep moving. The next thing we'll go over is a switch statement. Let's say data, we'll call it switch num, will equal 2. Now, in order to do a switch statement, we need a data object to return to. Now, the data object we'll return to, we'll define inline. How about switch underscore res for result equals keyword switch. Now, in the switch statement, we need to define the returning type. Now, if we defined switch res in a regular data declaration where we did give it a type already, we wouldn't have to do this, but we will do it here because we want a return of a string. Now we'll wrap everything in our parentheses and get started. We're going to switch over the switch num. So this is what will be evaluated. We want to use the keyword when. Let's say when the switch num is the number 1, then another keyword there, it is 1. And we could see that we're using characters here, but it will be converted to a string because of this implicit conversion here will be done. When 2, so if the switch number is 2, then we'll return it is 2. Finally, else it is more than 2. So that's our entire switch statement here. The period needs to be here instead after the parentheses. So what will happen here, we'll see the switch num is 2. It'll go through its whens. It'll start with this one, see that it's not 1, so it won't return this. It'll see that it is 2, it will return this, and it won't get to the else. So let's go ahead and outright what's going to happen. Switch res. We'll save it. I'm going to also Shift F1, make it look a bit better, and we will hit activate, and then we'll run the code. And we'll see it is 2. That worked perfectly. I'll clear this console so we could keep moving. I'm going to make this 20 now. We'll see what happens there. It should be more than 2. Activate. Run. It is more than 2, and that's how this switch statement works. Now, when we assign things like this, everything will always be converted to a string here, even though these are character statements. We could also make them string statements, like so, and that will be acceptable too. Now, if we were returning an integer, neither of these would work here. We can't convert these to integers, which would wind up breaking this statement. But let's take a look at what happens with our string here. We'll go into the debug mode. So let's save first. We'll double click on the side here where we want the debug point. This is the breaking point. Right click on it and just make sure you press refresh breakpoint activation. Sometimes the activation of those breakpoints doesn't work properly. Just reset it and it'll work for you. Now, when we hit this, we'll hit the ABAP debug perspective. Your perspectives are up here. The debug looks like the bug. The current one we're on is the ABAP perspective. So let's go ahead, save, and we'll run this after activating. We'll switch to our debug perspective. Now, in the debug perspective, we could double click any one of our data objects like this one, and we could see what it's all about here. We could see on 2, we're getting an actual type of string and what the value is right now. And we know, even though we gave it a character, we converted it to a string, so it should be a string. So this is what this is for, defining what the return type should be. And again, if we did this in a data type where we decided switch res is a string, this wouldn't be necessary. After the switch, we could just start the switch statement. Let's get rid of this and we'll do case statements. So let's go ahead, comment that in there. Case statements. It's important to note that switch is preferred over case now. Let's do data. We'll set up, how about case char for our case characters. And not in whens, we'll say, and period after that. Data, let's do case underscore result, type, C length 20. Now we'll see what I was explaining with the switch statement. Now that we defined the return here, we don't need to do any sort of conversion because the system knows what this should be. It should be a character of length 20. So let's get started on the case. The keyword is case. And what are we looking at? We're going to look at the case chars, period. Inside of there is where we do our when. So when, and this is going to be the result of case char, which should be not in when. So we'll just write I am an option, and then period. And under there, we'll assign case result equal to Let's say first when. We'll do another when. When I am second option, we'll set the case result to second when. And finally, instead of this else, we use when other. So when it's not listed up in the cases, what do? We'll set the case result equal to not found. After this, we have to end our case with end case, period, and we have it all set up. This needs to be an equals, and we're set up. Okay, so now we want to outwrite that case chart. Let's do that. Nope, we want to write the case results. Let's save it, let's activate it, and give it a run. Not found, because not in whens was not I am an option, and I am second option. It went to the when others, which means none of the whens were satisfied, and went to not found. Let's comment all this out. And we'll talk about inline XSD bool with logical operators. So when we went through types, we saw that we don't have a true-false type. What we do have here is ABAP true and ABAP false. Let's take a look at what that looks like with outrights. Outright, and let's use our pipes here. We could say ABAP true equals, and then open up some brackets here, ABAP underscore true, which exists in the system. Great. Now we'll do the same thing here. ABAP false. False. All right, let's see what we have here. Activate. And let's get rid of this. Clear. And now we'll run. We'll see that ABAP true is a capital X and ABAP false seems to be just empty space. So it doesn't have a true false like we do in many other languages, but we do have ABAP true and ABAP false. And to see if something's true or false, we need to access the XSD bool. Let's do that under here with data num for bool will equal, let's say 11. And now data, call it is larger than 10. And that will be equal to our XSD bool, and then wrap our statement. So num for bool greater than 10. So we're asking, is the num for bool greater than 10? And we're asking it to give us an ABAP true or false back that we can assign into this is larger than 10. So period there. Next, we'll outwrite the result of this. Is larger than 10. Paste it in there, put a period at the end. Save, activate, and run. We'll see we have our true and false, and we notice that this one is true. So outwriting this one is true, and that's how the evaluation is done in those if statements and switch statements and so on. The XSD bool will show us the evaluation going inside of those if statements and switch statements and so on. Is it ABAP true or is it ABAP false? Now I'm going to quickly write a bunch of different conditionals we can do here. So just give me a moment to get it on the screen. I'll write it in comments. So what we have here is an explanation of everything we could do. We can do an equal to operator, a not equal to operator, or NE, and we can use these interchangeably. I suggest that you use the symbols rather than the EQ, NE, less than, greater than, the GTs, and so on. The symbols are much more widely used. So this is everything we could do: equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to, and this interval test. Let's do one of the interval tests. The rest of them are pretty self-explanatory, and we've even done some of them too. We've done equal to, and we've done the greater than. So let's do the between. We'll set up our data is between equals XSD bool. I guess we'll use that num for bool one more time, and I'll just bring it down here. And let me bring that down. There's our num for bool. Now we'll say between as the keyword. How about 5 and 9? So is 11 between 5 and 9? Oh, I said boot, should be bool. And let's outright this. Let's get our pipes up. We'll say is between equals, and then is underscore between. Let's save it, activate it, and run it, and see what comes up on the screen. We'll say is between is empty, which we know for the ABAP false is the answer. Let's change this number to 8 and try again. And we'll see is between X, which is ABAP, true. I know I left us in the ABAP debug perspective, and of course we could still do work inside of that, but I'd like to show you how to move out of debug and back to the normal ABAP view. We'll talk a bit more about the debug perspective as well as resuming and stopping your debug, but just head right back. Right now we're in this bug here. Move to the ABAP, click that, and we're back to normal. If you want to be sure that your debug is finished, go ahead and just press this right here, and it's all done. We've gone through our conditionals, but there's much more ABAP left, so let's keep coding. It's time to make another class. We should be getting a little used to this. Go to our classes, right-click, new ABAP class. Let's name this class ZCL underscore tables underscore 55. We'll call it tables lesson. We'll bring in our interface. Click next. Select our transport request and click finish. We're going to talk a little bit about tables, which tables are available to us, and their big O complexity. Let me get this all on the screen and we'll go through each type of table. Here we are. Everything's on the screen now. So inside of my class run main, you could see that I started with a sample row. So we did a type, which is a structure, which we'll use to make a table. And we'll use this structure to make all of our tables. The first one we'll make is a standard table. So we're making standard tab, which is a type standard table of sample row. So it should have an ID, a name, a category, and a country. So inside of the table, we populated it with the value, and we could remember that with the value, we open up these parentheses, and then inside the parentheses, we can make table rows by opening up other parentheses. So we have this standard table. It has ID 1, ID 3, ID 2. We could see that that's not in order because it's not a sorted table. So we could do that sort of thing with a standard table. But standard tables do have their downfalls, and it comes when we look at the search complexity. Search is any column of the standard table linear search, O of n. That's a pretty slow search, and if the table is large, it will take some time. But this sort of table can be appended to without, say, the ID or a key in general. It doesn't need to be in order where other tables, say, if we tried to put in ID2 when ID2 was already there and we're up to 3, we wouldn't be able to do such a thing, so append would fail. But we could also modify the table, and we can sort this table since it isn't sorted already. When it comes to sorted tables, they're already done that way, so sorting doesn't work on them. Which brings us to sorted tables. Let's take a look at them. They look pretty much the same here. So we have our sorted tab is type sorted table of sample row. And we're going to give it a non-unique key. We could give it a unique key, but we're going to give it a non-unique key, and I'm going to give 2 keys this time, ID and name. With a non-unique key, having more than 1 key might actually help you search the table faster. So this would be sorted in a way where we have ID1, ID2, ID3. This would sort itself just 1, 2, 3. But let's say we put another one here, where we have another ID1. And we can make that anything. Soup, cooked. We'll go DE. So as this is sorted, it would want to take the ID 1s and then look at the second category and make sure that's in order as well in this ABC order, so it's able to find things a little quicker. With that in mind, the search works great as long as you keep on giving it members of its key from the left to the right. That's how it will arrange its sorting. So you'd want to give it the ID, then the name. If you had keys ID, name, and category, and you only gave it ID and category, you wouldn't speed up the search much at all. So we can ignore this first one right here. I'll show you this in just a moment. We're not going to be in that binary search. We're actually going to be here in that sorted non-unique key would be O log n plus a linear search. So a binary search to get to the point where it finds the IDs, and then to go through the IDs one by one. And of course, we could speed this up a little bit more by actually giving the name as well. So it could search through that sorted data in a way of O log n, and then wind up going O of n if it finds many of the same. This sort of table only appends if its key is in the correct order. In this case, it's ID and name, so they'd have to be in the correct order for us to append to it, so we would usually use a modify statement to update this table. Now, if we got rid of name here, now we no longer have ID and name as key, we just have the ID as a key. And what we have to do in order to make this table faster is make it a unique key. So now a sorted table with a unique key can't possibly have 2 IDs that are the same. So we'll get rid of this soup one. But this is a very fast table because with these unique IDs, the search will be done as a binary search, O log n. And let's look at our fastest table, the hashed table. A hashed table needs to have a unique key. That key will be used to create the hash. Then the hash will be used to do the search. The search is extremely fast. It's O of 1. It is direct access to the information. It's sorted by that hash. Searching without the full hash is just as slow as a standard table. So if you have more than 1 key here, you have to make sure you search with each member of that key. You want to modify to update this table as well. Now think about that unique key for a moment. Say we gave this hash table just the ID. When it created the hash, it used the ID and the name to come up with the hash. So when it goes through that hashing algorithm again, it cannot find it using its hash. So it needs to be searched just like a standard table, making it very slow. So if you are to use a hashed table, make sure you use it in the case where you're going to provide the entire key. Let's look at what these outrights look like. They should look exactly the same, with the one caveat that the standard table will have this ID 3 in the middle, and these other ones will go in order. So I will save, activate, and run. And we see we have 3 tables. The first one is 132, like we mentioned. We wrote them out of order because we can with a standard table. And the other 2 look just the same because we were not looking at the hash itself. We're just looking at the table. I do have one more point about the sorted table that we should go over. So if it needs to be a unique key and we give it 2 fields as a key, we could have 2 fields with the same ID, but they couldn't have the same name. If they both matched, it's no longer unique. So a unique key with 2 fields mean those fields put together are unique. We learned a bit about tables, and now we should put that knowledge to use. So let's keep coding. It's time to get our hands on some tables and do some table manipulation. Let's go over to Classes and right-click. New ABAP class. We'll call this one ZCL_internal_tab_55. We'll call it internal table lesson. Let's get our class run. Click next, select our transport request, and click finished. We'll create our table row type. So start with types. Begin of. Let's call this one employee_row, comma 2 ID. That type will be I. First_name. That type will be C. Length 20. Let's do last_name. Type C. Length 20. Department. Type C. Length 2, and full name. Type C, length 40, double the first and last name. Now we say end of, and the name of this was employee row. Data, employees_table, type sorted, table of employees row. With, let's do, we could do a unique key. With unique key. And we'll make it ID. Oh, I called it employee row, not employees row. It would be 1 employee per row, so that makes more sense. Let's assign our value. Employee_table equals value. Put up your hash and open up those parentheses. Inside those parentheses, let's get to the next line and open up some more parentheses. So we'll do ID1, first_name will equal Papa, and last_name will equal Santo, and the department will be IT. Our second person will be ID 3. We'll have a first_name equal to Katie, a last_name equal to Carney, and a department will equal HR. And its employees table, that'll fix that. It also wants a space here. You can see it doesn't like that there's no space after that. And we're good. So we've populated this table. Let's write what's there. I'll clear the console. Make sure we save, activate, and run. And we see our table. We have these 2 IDs, we have the names that we put in, and departments. We do not have a full name, but we will get to that. We're going to talk about inserting an internal table. We'll write that here, inserting a table. We'll write. All right, so the first thing I want is data. Employee is type employee underscore row. So we're making a single employee using the structure of the employee row right up here. We could populate that using dashes by typing in, let me move this back, employee dash, and it'll tell us everything that we could put in the employee. Let's start with the ID. I see that we have 1 and 3. Let's put this person right in the middle at 2. Employee dash, and let's do first name. We'll do the first name of Lisa. Employee dash again, last name. Last name will be Turtle. And finally, employee dash department. And that will be SA for sales. If you were with me on the tables video, we spoke a little bit about what happens when we append a table. And since we have a unique key of ID, we can't possibly append an ID2 to a table that already has ID3 in it sorted. So the way to do this is to insert the table with the keyword insert. We want to insert, and then we give it what to insert, the employee that we just created, and then where to insert it into, table, and the table name, employees underscore table. Now let's take a look what this looks like after the insert. We'll save, and we see it after the insert. So we had on the first run just 1 and 3. We're able to put this one where it's supposed to be. Now it's 1, 2, 3 with Miss Lisa Turtle in the middle. But what if we want to change a row that's already there? In order to do that, we will use modify a table. So the first thing we'll do is clear this employee. So clear employee. Now the employee structure is empty. I'll take everything from here and we'll just put in some new values. We have our employee ID. What we want to do with our employee ID is target something in this table. I'm going to target employee ID 3. That would be Katie. We're going to change her first name. How about to someone? And her last name will be works here, hyphenated. And she could work in sales as well. That'll be just fine. Now we'll take this person and put them in the employee table where Katie is. We're really doing an update, or as we call it here, a modify. So modify table, and then the table name, employees underscore table from employee. And we could take a look at what this looks like. Save, activate, and run. And we could see that we have someone works here instead of Katie Carney. So the modify allows us to update a row just like that. Let's try something against the rules and see what happens. Let's mark this failed insert. We'll do a direct insert here. We will insert value, put our hash up, and let's make one person. We'll do ID equals 2. So we're inserting an ID of 2. It's there already. First underscore name, let's equal no. And last underscore name, let's equal name. So we have no name here. And the department will also equal HR. We'll do this in line with into table and then employees underscore table. Here we're trying to insert a value with an ID that already exists. It needs to have a unique key. We should get a failure here. And in order to see that failure, we want to check the system sub RC. We'll do an if statement to give that a look. sy-sub RC. So if sys sub RC equals 0, what will we do there? So a 0 means that everything was done properly and no error was returned. So we'll write inserted. Else, meaning the insert did not work properly and we have some sort of value in our system sub RC, I'd like to data, and we're just going to hold the system sub RC in this element. We'll call it sub RC. And that will equal the system sub RC. And then we'll write. Let's put up our pipes failed sy-sub RC equals, and then we can put that up there, sub RC. Let's end our if. And we can see what happens here. So I'm going to get rid of this for now, this outright statement, and we'll see what we get back from this. And we could probably just empty this out here. Clear the console, I'll save, and let's see what we get. We got failed, sub RC is the number 4. We've demonstrated a failed insert, and we've seen how to do some error handling in a very basic way. Let's talk about filtering a table. We'll use the table that we've been using. We'll write data filtered tab, and that will equal filter as the keyword, hash, and open up some parentheses. Inside of there, pick the table, which will be our employees underscore table, the word where, and this is where we put our filter condition. I'll say ID less than 3. So what we expect back is everyone in the table with an ID less than 3. And we have 1 and 2 in there, so we should get 2 rows back. Let's take a look at what we got. That's exactly what we got. We have ID 1 and 2. This is a great way to filter a table by conditions. And instead of using this filter keyword, we can also read a table given some conditions. Let's use reading tables. Okay, so we'll say read table. Those are the keywords and the table that we want to read, the employees table. With key, and then we say the key. Let's do ID equals 2. Into data. Now this is where it's going to be read into. I'm going to call it employee 2 since that's who we're looking for. Let's outwrite that employee. And we see our employee number 2, Lisa Turtle, in sales. If you're looking at this and saying it looks a little clunky and maybe a little backwards from everything else we've seen, ABAP has us covered there too. Here's a much easier way of doing it in a way that I prefer. We'll write data. We'll wrap now employee 1. We'll get employee 1 this time. That will equal the employees table. Now just open up brackets and put your condition in there. I'd like the ID to equal 1. And now we'll outwrite employee 1. And we do have employee 1 right here. Of course, we had employee 2 written right before it, but this to me feels a lot better, and it keeps where the data is being assigned on the left side, which is a lot of what we do, so it feels more comfortable for me when I'm writing it. Now let's modify this table like we did here, but with the row that we took from the table. This will happen a lot when we do some loops. So we'll modify the table with the row we took from it. I'm going to get rid of these outright. And we'll use employee 1 to do this. Let's say modifying with row. We'll change something about employee 1. How about employee underscore 1 dash full name equals oops. So something went wrong. Now just use that employee to modify the table. So modify table employees underscore table from employee underscore 1. Then we'll outright employees underscore table. So now we should expect the table to have our first employee, number 1, that's Papa Santo, and IT to have a full name of oops. Let's see what we get. And we do. The ID 1 has a full name of oops. Now, we've been making structures and using them to create tables, but in ABAP, we could take tables and use them to create structures. So we'll do that. Table to structure with like line of. I'll clean up a little bit so we don't have this outright going anymore, and I'll actually leave this for right now. So like line of, let's get it started. Declare another data object. So data, let's say tab line. So a line from the table is like line of employees underscore tab. Period after that, and we will write table, and then period after that. Let's outright tab line. Now we'll see what a table line from the employees table looks like, what its structure is. And we could see the structure, ID, first name, last name, department, and full name. And we pulled that from the table. So that time it was table giving us the structure rather than a structure being made into a table. Well, let's populate that full name column. We'll do some loops. This will be a basic loop. Let's write that here. So we will loop at, and then we have to put the table in. So employees underscore table into, let me do capital, into, and we'll do data. And the data will be employee underscore line. Now the loop has started. What we need to do is end the loop at the end. So we'll just write end loop now, and all our work goes in the middle. Now each row from the employees table is going to be read into employee line one at a time from the beginning. We can access the employee line by typing employee line. And then we could dash to what we want to change. So let's use a dash and go to full name. We'll use our string interpolation in order to take the employee's first name and the employee's last name to make the full name. So employee underscore line dash first name. And here we'll do employee underscore line dash last name. And that should make the full name. But we're not done yet because we haven't put this back into the table, and we could do that with something we just learned, the modify statement. So modify table employees underscore table from employee underscore, I spelled that wrong, employee underscore line. And we should outwrite that employees table. So let's see what this looks like after we loop through everything and assign to full name the first name, space, and the last name. Here we have the first name, space, last name. Same thing with each one of them. So that's how that loop worked, and we're able to modify the table. But what if I told you we can do this faster and with less code? Let's give that a shot. We're going to talk about a very special operator. It's called the field symbol. We use the field symbol in loops in order to reference the data that's in memory. So we don't bring the data into the loop. We leave the data where it is, reference it, and do our changes directly, which gives us two very big improvements. One of them is speed. It is much, much faster. And the other part is we don't need to use the modify table statement. We are already changing the area in memory where the table exists. So let's see what that looks like. We're going to loop at the employees table. Now, instead of saying into, we're going to say assigning field symbol. And here you just want to put the pointers around it, those arrows. And fs underscore will say employee. Fs, of course, stands for field symbol. Now we started our loop. Anytime we start a loop, let's make sure we end the loop. Inside the loop, we'll do our action. And what we'll do is field symbol, employee, close, and then we can just dash to full name. That can equal basically what we did last time. We'll put up our pipes, we'll put up two of these with a space in the middle, and we'll do fs underscore employees dash first name. And we'll do the same thing for the last name. Close that statement. And now let's see before and after. Of course, I've commented out the loop before, but we see here the full names there. So we'll actually write this before, and then we'll write it after, so we could see the magic take place. We see that this is less code. It's also way faster, and we don't use our modify table, and that's really why it's less code. So we'll save, we will activate. I'll get rid of this here, and then we can run. So here we see before we hit this loop, we even still had that oops in there from before, and after we hit the loop, even without modifying the table, it wrote directly to that memory space and gave us all the full names. So what's going on here is we're dealing with basically a reference, and we can actually do this with a reference. We'll do that quickly next. We still do the same loop at, so loop at employees underscore table, but here are the new words. Reference into, and then data. We'll call this employee underscore ref. Let's end the loop and do our work inside. So now we'll say employee underscore ref, and here's something that's much different. We just have a reference, so we need to use something called the dereferencing operator, and that is a dash and an arrow. So that's our dereferencing operator, and now we can see what's inside of this reference, and we see everything that we need. We want to go to the full name, set it equal, and do the same work with some pipes. We'll say employee underscore ref, and let's point to first name. We'll do it one more time with the last name. Put a period at the end. And we can outwrite the employees table here as well. We'll take both of these, put them where the reference is, and then get rid of this. So we should have much the same data, but we're using references directly rather than assigning a field symbol. And both of these are faster, much, much faster, and they do not need the modify table expression. We'll save, activate, I'll clear the console, and we'll give this a run. Great, that worked just how we wanted it to as well. Let's use the debugger to see what's really happening inside of this referenced loop, this reference into data loop. So we will out write employee underscore ref. Double click here. Oh, I have to save first, of course. And then I'll double click here. I added my breaking point. Every time I add a breaking point, I generally like to come here and refresh breaking point activation. So when this does break right here, we'll take a look at the debugger. Let me get rid of this too. And into the debugger we go. Now we're in the debugging perspective, the one with the bug here. We were in the ABAP perspective over here. Now the debugging perspective has a lot of information for us. Like, I would like to see what the employee ref is without outwriting it. Let's take a look. You can see that it's the value is basically a memory space. It's not an actual value. That's why we dereference it to get to, say, the full name or each part of the structure. And when you're using the debugger, all your tools are right up here. If I want to continue, we can resume. Also, F8 works. If I want to stop the debugger, we could click terminate. The cool thing about debugging inside a loop is if I continue, it'll stop at the next debug point, which will happen again. It'll hit the end of the loop, head back up, and then hit the same debug point. So let's see that in action. There we go. And we know we have 3 of these, so this should happen again. And I think that's all we have. So now this should end. And here we are. It's exactly what we're looking for. And this is one of the reasons I put us through the debugger rather than just doing this outright. I wanted to show you this. So this outright is dereferencing for us. So it did that outright at the end, which was 3, someone works here, but it should have done that over and over. Yes, it did. So it dereferences for us, so we can't see that weird memory space type thing going on that I was able to show you was the real value of this reference. Let's get out of this ugly debug. Back to normal. I want to talk about one more keyword that comes in handy with these tables. I'm going to get rid of all of this. Now the keyword is base. We can see base in action pretty quickly. I'm going to grab the first employee. I have it here somewhere. Okay. Well, we actually have employee 1. So if you remember employee 1, we got it from here. So I'm going to get rid of this here, and I'll just bring the code down. All right, so we have extracted employee 1 from the employees table, and we're going to use base in order to update the table from this employee 1. Now, this means that the employee 1 exists. It has a structure, and it has the data inside of it. We're going to say, hey, keep everything about employee 1 except for what I change. So we'll use a modify table statement and give this a shot. So modify table employees underscore table from now value operator, and inside of there is where we do our base. First thing we'll write, base. Then we'll give it what the base is. Our base is the employee underscore 1. So everything that's in employee 1, leave it the way it is, except for what I tell you to change. So what should I change? Let's change the full name, and we'll make it, this is a mistake. And you could see I don't have a separation between value there. That should fix that. We'll head down and we'll write employees underscore table. Let's save, activate, and run. Let me just clear this quickly. And run. Here we go. So we were able to keep everything that's in employee 1 and just change the full name by using base and saying, hey, use these as the values, but just change this one thing. So we learned a lot about tables and saw a bit about looping through tables. There's still a lot more ABAP, so let's keep coding. We've done some table loops, but let's move on to do some other loops. See what ABAP has to offer by clicking Classes, right-clicking it, New ABAP Class ZCL, Looping, underscore 55. And we could just write loops lesson. That's just fine. Make sure you add the class run interface. Next, grab your transport request and click finish. Let's get started with a while loop. So, while loop. How does this work? We write the keyword while. We'll have access to the system index here. So that's what we'll use. System index less than or equal to 5. We'll write the system index. And we have to end while. Let's save that. Let's activate this and hit F9. We have 1, 2, 3, 4, 5. So it went through until it hit the number 6, saw that that was over 5, and stopped. So the while loop is pretty simple to work with. There's also a do loop. So let's say do as the keyword 5, so same amount of times. So those are the two keywords, do and times. Put a period there. Let's end the do. And in the middle is where we do our damage. We will do the same thing. Outright our system index. So this should come out exactly the same. And it did. 1, 2, 3, 4, 5. In these loops, we can also do something called exiting. Let's do an if condition that results in us exiting if the system index is equal to 3. So if equal to 3, we'll end our if. We'll write the word exit with a period after it. Now let's see what we get. 1, 2, 3. We also have a for loop, but I'm going to use this do loop to just populate a little piece of a table. I'll actually take it from our internal tables. Let's see, up here. Here we go. We'll change this a little bit, but I'll just take it from here for now. Actually, we'll leave this here. We'll do another do after it. Okay, so I want a non-unique key, and I do not want a sorted table. I just want a standard table. And let's run that do again. So do 5 times, period, and do. And we're just going to populate the ID. So we will append value ID equals the system index to employees underscore table. Then let's read that back. And there we have it. We have our table. We've only populated the ID 1, 2, 3, 4, 5. So let's use our for loop to manipulate these IDs. I'm going to use this for loop to do some changes to the table and write back to another table. So we'll need to make that secondary table. We could just copy this one down and change the name. We'll call it for tab for for table. And we'll set it equal to the operation of this loop, which we'll set inside of value. So the loop will write back to the table, basically. Let's take a look at how that works. For table will equal keyword value, hash, and open up those parentheses. Inside those parentheses is where we'll write our for loop. I'll move to the next line to do that, like so. Okay, so in there, keyword is for. We'll say EMP for employee. In employees underscore table. Now open up your parentheses and we'll do our operation. I want the ID to equal the EMP, so the employee and employee table, EMP dash their ID multiplied star asterisk 3. So the ID times 3. And they're warning me this should be for tab. Great, and now we'll outwrite this. Okay, so activate, make sure we save, activate, and then we can run it. And see, we have now 3, 6, 9, 12, 15, which is 3 times 1, 2, 3, 4, 5. And just as a quick bonus here, what we're going to do is change the order of this table, reverse the entire table from this ascending format where we're 3, 6, 9, 12, 15 to a descending format, 15 to 3. So all we have to write is sort. And then the name of the table, which was the for tab, by, and then which element inside of those structures would we like to sort it by? I'd like to sort it by the ID. But I'd like to sort it by the ID descending. Here we are. And I'll grab this guy, put him below that, and we should be able to see this now descending. Here we are, 15, 12, 9, 6, 3. So we just did a little bit of math, but ABAP has a lot to offer, so let's keep coding. Let's get started on some math expressions. So up to classes, right-click, new ABAP class, ZCL underscore math underscore EXP underscore 55. We'll say math lesson. Add in that interface, the class run, OK. Next, then choose your transport request and click finish. We know we have different number types. We'll start with an integer, and we'll talk a little bit about packed numbers. We should see a float in here at some point. So let's start with an integer. So data, we'll call it num, and the type will be I for integer. So what can we do with math here? Num equals 1 plus 2. Okay, so and we'll outright num. And of course, we should get 3 here. So save, activate, and run the code. And we get 3. So we're at 3 now. Let's see what else we can do. We could use num inside the equation itself. So we're at 3. We'll do num plus 1 should bring us to 4, and we'll outright that. And there we are at 4. Okay, but what if we want to do a addition right in line? That'll be the plus equal. So from 4, we'll go to 5. There we are at 5, and we could do the same with subtraction. We could do everything above, like 2 minus 1, num minus 1, and so on, or we could minus equals 1. That should bring us back down to 4. And it did. Let's do some quick multiplication. Num will equal, let's do 2 times 3. Get rid of everything else before it. And we see that 6 as it should be. We'll do some division. Num equals 4 divided by 2. And we get 2 there. When do we have problems with these integers? We can have a problem with something like this. Num equals 1 divided by 8. Let's see what we get there. We get 0, because the answer should be 0.125, but we don't have any decimal places with integers. So it's rounded to the closest integer, which here would be 0. But what if we want to see the answer of 1 divided by 8? Let's get rid of this. We'll make a new data object. Let's call it pack. We know that to be the type of P, packed number. It'll have a length. We'll give it, how about 5 on the length. And the decimals are what matter to me. We'll give them 3. So we'll do pack equals 1 divided by 8, period. We'll write pack here, and we'll see what we get. 0.125, as we should get there. All right, so let's pick it up from here. I'm going to outright num again, because I'd like to show num equaling 3, and then to the power of is 2 of the stars in a row, so 2 of the asterisks. And I'll go to the power of 2, we'll save that, and we'll see what the output is on that. That's 9, and that is 3 to the power of 2. And finally, we'll use mod, the modular. So what mod does is it's going to take whatever the remainder is of division. So we could do 3 mod 2, and the remainder will live in num. So let's see if we get 1 as we should. The remainder of division is 1, and it's right there. Let's take a quick look at a few things now. Now, if we outright directly, we'll see what the native results are of this sort of thing. And I suggest you do this with all sorts of different operators, even maybe use the div operator rather than the slash sign that we use for division, and so on, see what the outputs are. But let's see what a few of the outputs are. So let's do 3 times 2 and take a look at that output. 6, so that came back as an integer. And what about 3 to the power of 2? That came back as a floating point. So it is important to see what's coming out of these equations and do conversions if you need to. If they aren't able to do them implicitly, you might have to explicitly convert some stuff. So let's take a look at explicit conversion. Let's set pack up to be 0.597. And we're going to convert in this write statement here. So I'd like to just write it inline for all of us to kind of read out after. We're going to write converting a pack to an int, and the number was 0.597. And then after that, we'll have the actual result. And the result should be conv, that's conversion. And then what do we want to convert to? I want to convert it to an integer, and then wrap what we want to convert, pack. Okay, let's put a period at the end of this, and we could see this write itself right to the screen immediately. So F3, and we'll go to F9, converting a pack to an int, and you'll see that it actually rounds it up to 1. And since I did mention the div possibility, I'll get rid of this for right now, and let's just do pack equals, we'll do 1 div 8. And so div does work differently, and you'll see with the outright what's happening here. So when I press F9 here, you'll see it's 0.0, even though the answer to this question is 0.125. So when you're using div, obviously things are rounding. There's also a powerful built-in function called reduce. Let's take a look at that. So we need some data to return to. Everything from the reduce equation will get put into what I'm going to call total. And that's going to equal keyword reduce. And then our return type, which will be an integer. We'll open this up. Let's put the period after it. And let's give ourselves some room here. First thing we do is init. So we can init a variable here, or a data object, sum equals 0. And then we give it what it is we want it to do. So the for condition is I equals 1 until I equals 5. And let me put this capital. I like to do the keywords in capital so everyone can see them a bit better. And then we give it what it should do next every time through this reduce loop. Sum plus equals I. So it's going to sum up the numbers from 1, 2, 3, and 4. That all together should be the answer here, and let's see if that's what we get. Out, right, total. And here we are. We get 10, and that is the answer. It's 4, 5, 6, 7, 8, 9, and then 1 added to it is 10. So reduce works like this, and you could do quite a bit with it. You don't just have to sum like we did. We've learned a bit about the mathematical operators, but there's also characters and strings, because ABAP has a lot for us. So let's keep coding. It's time to talk about strings and characters, so let's head over to classes and we'll make a new ABAP class. Let's call this one ZCL strings underscore 55, and strings lesson can be our description. Add in our interface, and OK. Next, grab your transport request and hit finished. Let's make ourselves some data to work with, so we'll write data. And this first one we'll call string data. We'll use backticks. I am a string. And then we'll do data char data, and then single quotes, I am a char. The first thing we'll look at is the length function. So length. In order to get the string length, we'll outwrite str len. That's the string length function. Inside of there, let's write in our string data, put a period at the end, and let's activate and run this class. I'll clear this real quick as well. And here we are. There are 13 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The empty spaces do count as characters here. So how do we do this with characters? Let me label this string length, and we'll make the next one character length. Char length. So out right here, the word is num of char. And inside of there, we'll put our char data. Let's save, activate, and run. And we see we have 11. Let's count those out quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's how we do lengths on strings and chars. Let's look at a few more string functions. Let's outwrite these directly. The first one we'll take a look at is toUpper. So to_upper. This should change everything within the string to uppercase, and let's put the string in there. String_data. Save, activate, and run, and let's see what it looks like. I am a string, and it's all uppercase there. Now let's see the next one, which I bet you can guess. It's to lower. So we'll write to lower, and we should be able to see it come in uppercase, then lowercase. I'll clear this. And there we are. So we had our toUpper, where everything was uppercase, and toLower, where everything was lowercase. We'll comment this out. Now let's talk about replace. We'll write this one in line as well, outwrite. The keyword is replace, and we'll open our parentheses. Inside of those parentheses is where we'll put our val. That's the starting value where we'll do the replacement. Inside of there, we could put in a string. I'll put in, I am Batman's buddy. Now we'll write the substring we would like to replace, and I'm going to make that the letter B. And what would we like to replace that substring with? Let's say with, which is the keyword, the letter F. And then finally, we're going to write occurrence. We'll write, it's OCC for occurrence. We're going to say occurrence 1. Let's see what the output of this is. Now we'll run. I am Fat Man's buddy. Now, what if we wanted to replace all of the occurrences? So we'll say occurrence 0. And let's see what comes out for that. I am Fat Man's fuddy. So it replaced both B's that time. What if you want to replace the last B? -1. I am Batman's fuddy. So that's how you do this. You'll do the occurrence of the substring and then say which occurrence you would like, the first one, the second one, or when you go negative like this, which from the end would you like, the first one from the end, the second one from the end, and if you want everything replaced, we use 0. Let's keep going. Let's talk about substring. So we will outwrite. The keyword here will be substring. Inside there, we need our starting value, and we'll write that in line. How about I am Pac-Man this time? And if we want a substring, what we'll do first is an offset. So this offset says, where do we start the substring from? And that's all we'll do with this one. Let's outwrite this. And we see from 2, it starts writing the rest of the string. So the offset was 2 places, 1, 2, so mpacman was written. So we know how to start a substring from an offset, but how do we end a substring when we've reached a point? Let's do this. I'm going to copy this down. And here we'll just add the word len for length and say that equals 6. So we'll get 6 characters after the offset of 2. Let's see what that looks like. mpac. We can also start from the beginning. So let's take this down and do it one more time, just starting from the beginning. We'll leave out off. We'll just have the len, which means the length, and we'll see what that comes up with. imp. Let's talk about doing this with characters now as well. So we'll write char sub chars. So the sub characters involved. These chars are a bit simpler. We'll just outright, let's use our char data, and then hit +2 and put a period after it. Let's see what we have there. We get ma-char, so it took out those 2 characters, I and the space. ma-char is still there. Let's do a few more. If we want to do the same thing we did up here, let's do +2, and then we'll put some parentheses here with the number 6 in it. So we want 6 characters after the 2. And consolidate that in. We can't have any spaces around here. mac, and then next we'll do the final way. We'll get rid of the +2 and just do the 6. And we see ima. Let's finish up our string substring functions. So we'll do some more substring. We'll use the keyword substring from. So outright substring underscore from. We need to give it a val. We'll give it a val of mpacman again. We'll work off that same value. And we'll write sub equals am. Let's see what that gives us. It gives us mpacman. So substring from where it finds the sub. So that's what happened. It found m there and it left off I and the space. Let's do another. On this one, we'll do substring 2. So substring 2 will start the beginning and include the substring, so I am. And here's another one called substring after. We see it is pacman, so it waits until m is found in the string and gives you everything after that. You can even see that it left a space here. That space did not disappear. Let's do another. This one is called substring before. So this one just leaves us with I, and I imagine a space. Yes, it does. We have the space after it. So this is how these substring functions work. If you do the substring from, it will include the sub. So from and to both include the substring. If you use after and before, that would not include the substring. That would be exclusive of the substring given. Let's talk about find. So we'll outright. The keyword is find. It needs a value. We'll give it the same value, I am pacman. And it needs a sub, which will equal about PAG. We'll put a period there, and we know that this should not be found. Let's make sure we move this over for it. And since it's not found, it returns -1. But what if we could find something? What would it spit out then? We'll write pack. We know pack is in there. And let's see what we get. It says 5. So to get to 5, we will start 0 index, 0, 1, 2, 3, 4, and place 5 is where the substring pack starts. And in a lot of these string functions, you can give it regex. I'll show you what that looks like, but we won't do much of that. This isn't a regex course, and regex is a topic within itself. This is what they write to use regex instead of sub. What you would use is PCRE, that's the type of regex, and then we put in our regex statement. It could be something like capital A to capital Z, and this would be all capital letters, and there's quite a few things you could do with regex, and I believe you should check that out online. It definitely will help you out if you're doing a lot of work with strings. Let's talk about find any. Find any of. We'll grab this, and we'll just change the keyword to find any of. Find underscore any underscore of. Same here. And let's see what we get for these two. I'll clear the console. And we'll see we get 2 for both of them. So why is that? The reason that we get 2 for both of them is we don't need to match the entire string, and they both start with PA. So if we're 0 indexed, we'd start at 0, 1, the A comes right here, and that's where we get our matches. Now if we were to change this like so, let's see what we get. We can see we get 2 and 5 now, the 2 still being 0, 1, 2, and the 5 being the P, 0, 1, 2, 3, 4, 5. So with find any of, when you make a sub here, the substring you're looking for, if any of the letters match, it will return where it first found it. All right, let's move forward to reverse. Here we go. Reverse. So we'll outright reverse this string. And we get this string backwards. Now we'll do insert. And we'll outright insert, which is going to take the val, and we could use the same one we just used. The sub will be what we'd like to insert. Let's say is A. And let's put spaces around that. And then finally we have our offset, off, and we'll make that 4. Just going to comment this out, and then we could run this to see what happens. This is a string. And you could see I actually added an extra space at the end there, so it would be better like so. Now we can concatenate. Let's take a look at that. We've done quite a bit of concatenation with our string literals that we have, but let's do it with the concatenate keyword. For this, we will need some data, but we'll do it inline. So we'll write concatenate the strings we'd like to concatenate. So this is, and the second one will be a string. And we'll put it into data concat underscore res. And we'll outright that. let's get rid of this one here. We're getting a little messy in the console. And we'll do that again. This is a string, and we do need a space here, so we could have possibly made the space there, but there's another way to do this with a feature of concatenate. We'll copy this down. Let's get rid of this. Here we are. All we have to write is separated by, and then what we want it separated by. I'll use a space like we want. We could take a look at that. That looks much better. Now let's do split. I've been writing a lot of the strings in line, so I'll do this with the data object. We'll do split me to hold this string. And the string will be split me. Let's put a comma here. Give us something to split on. Keyword is split, and then we'll give it split me, which we just created, at, and then what do we want to split at? The comma. Into data, and we're going to need to do this twice since we're splitting it into two pieces. So the first piece, let's say split 1, so S1, and we'll have data S2. Now let's write that out. Out right, and we'll do S1 here, and we'll out right, we'll do S2 here. We'll save, activate, and run that and see what we get. We got split, and then we have the space and me, and see that the comma is removed. Now we'll talk about shift. Let's do data shift me. That will equal shift me. So we'll say shift as our keyword, and we'll give it what to shift, which is the shift underscore me, and then by what? I'll say 2 places. And we can out right shift me. And we see the 2 places at the beginning got removed. Everything was shifted to the left by 2. But what if we want to shift to the right? Here's how we'll do it. I'll grab this shift me here. And before by, I'm going to just say right. So shift me right 2 places. Let's take a look at that. There it is. Now it has 2 spaces at the beginning. It was shifted to the right by 2. And now if we don't want to add any space or get rid of any characters, we could do this one more way. So we'll shift me circular by 2 places. And we see what happens if the mesh. So that SH winds up getting to the end. We can also do shifts in a more functional way. This is how that would look. We'll write shift underscore left, and then we'll wrap our val, which should be shift underscore me, and the amount of places we'd like to shift it, which can be 2. And I shouldn't forget to outright this. And let's see what we have here. So we see it works just the same as the shift me, which is really a shift left. As we could see, the regular shift always shifts left. Then we had the shift right, the shift circular, and the more functional style of shifting, just like this is how you do those types of shifts. Let's do one more. I want to do a shift up 2. So we'll make some room for that. We'll write shift me, up to, and how about, what do we have in there? How about till ft? And let's save that and see what comes out. There we go. It's ftme. And we're just going to do one more. This one is called condense. This one can rid you of spaces in your strings. So we'll do data condense underscore me, and we'll leave some room at the beginning. We'll write condense me. And I left a space at the end as well. So we'll out, right? Condense underscore me. And let's do our work in front of that. So the word is condense. And then what you'd like to condense, which is condense underscore me. Let's see what we get out of that. Condense me with no spaces at the beginning or at the end. But what if we want to get the middle space out as well? We could just use condense me again, like this time. No gaps. And we have condense me with no gaps in it at all. So there we are with some string and string functions, and we even got some character work inside of there as well. But as I said, ABAP has a lot to offer, so let's keep coding. Up to now, we haven't used any tables at all, so I'd like to create a table we can work with. We've used some internal tables, but I mean a true database table. Let's create one now. We'll go up to our ZPack language file. We'll go to new and other ABAP repository objects. Start typing in table, and you'll see database table. Double click the database table. Let's name it ZTB for table, DB, and we'll call this lesson. So underscore 55, we'll call this DB lesson. So database lesson. Next, we'll grab that same transport request and say finished. And we're going to define a table. I'll explain what we're doing as we do it here, but we won't go through this too heavily. This is something we do a lot of if we did a RESTful application programming course, which we could do in the future. If you would like to do that, please let me know in the comments. So what we have here is a table. It's going to have a label on it, DB lesson. We don't have to worry about any of this for what we're doing right now. We can see that we have a key that is the client that has to be an abap.client, CLNT, and it has to be not null. We're going to give it another key, and we've been doing this a lot. We'll call it ID. And we'll make that in abap.int4. And we'll say not null as well. That can't have a null value in the database. Let's bring the name. And that will be abap.char, and let's do 20 here. And you could see we're kind of doing what we did in an internal table. We're defining a structure that we'll use within this table. Next, we'll do description. That will be abap.char, and we'll let that be 40. And finally, we'll do last changed at, and that can be time stamp L. And you know what? We'll add one small field. How about country? Country will be a small field for us, so we'll go abap.char, and we'll give it 3 characters for that. Now save and activate. After activation, we could right-click here, go to Open With, and hit Data Preview. And this is our data preview. We had our client, our ID, name, descriptions, country, and last changed at. Don't worry about client at all. ABAP will handle that for us. We're just worried about the rest of it, the ID, name, descriptions, country, and last changed at. Obviously, there's no data in it yet, so we will insert some data. In order to insert data, we'll need a new class. So we'll go to classes, we'll right click it, new ABAP class. Let's call this CCL underscore database underscore 55. And we'll write database lesson class. Let's add our class run, hit next, grab your transport request and click finished. The first thing we'll do is inserting the table. So we're inserting a database table here, not an internal table. We'll use an internal table in order to insert the database table, but we want to persist the data in the database, and that's what we want to get done this lesson. So the first thing I want to do, I want to create a data object. Let's call it pop tab, which will stand for populating the tab. It'll be type standard table of, and it's going to be the table we just made. So you can see the name right there, ZTB underscore DB underscore lesson underscore 55. You'd hit period there. So it's going to, from that table, derive a internal table. The other thing we'll need is a timestamp, and this comes in handy a lot. So you just write get timestamp field, and then you put yourself up a data, and where do you want to save that? I'll call it T underscore stamp, so we could grab that whenever we want as the current timestamp. Now we do need some data to populate the table with our internal table, so we'll write pop underscore tab will equal value, and this will look like what we've done a few times before in this course. So we'll open that up, and then we'll want to make our rows inside of it. Let's do 1, 2, and 3 rows. I'll type this in and fast forward through. At the end of it, you can pause if you'd like to copy with it, but this will be a lot of typing and take a bit of time here. And there are the values for our pop tab. You could give this a pause and copy them down if you'd like to. Otherwise, we'll keep moving forward with a try catch block. So try, after this we'll write catch, and at the end we write end try. So that's the entire block. We have try, catch, and try. What we're going to try is to insert ZTB. So this is the database that we'd like to insert. So ZTB underscore DB underscore lesson underscore 55 from table, and the one we just made, pop underscore tab. Hit your period and you'll see a problem right away. It doesn't like it done this way. It's actually not allowed to be done this way. When you're inserting like this, you need to have an escape character, and that is the @ symbol. There you go. Now in the catch, what is it we'd like to catch? We'd like to catch a certain error type. The error I am looking for is CX underscore SY underscore open underscore SQL underscore DB. And we'll catch that into data xref. So it's an exception reference. And if that happens, we're going to want to get the message data out of there, get the text out of the actual error, see what the error is. So we'll write data msg underscore text, so message text, that should equal xref. And then we're going to enter that class, and we will talk quite a bit about classes here. When we use this single pointer, we're entering the instance of that class and seeing something. And what we're going to see has to do with the interface message. And then we have to use this tilde, this squiggly line, and we want get text. And that is a function, so, well, It's really a method, so we do want to execute that method. And let's outwrite what happens there. MSG underscore text. Get your period, and we have our try catch made. So if we attempt to insert this table and we have a problem inserting it, it should hit our catch block and we should see a message written out to the console. I'll clear the console and let's give this a shot. The first one should not give us any trouble and should write properly. And just quickly before that, since it should write properly, let's outwrite that it did. Success. And we have our success. So we should be able to go back to our database, the table that we made. Let's right click it and let's go to open with data preview. Here's our data. It's actually in the database. So that is the big difference. This is actually being stored inside the database now. Let's take a look at our database file one more time, our definition here, our defined table statement. We see what we have here is a key of ID, which means that has to be unique as it enters the table. So when we go back to our class here and we try to run this a second time, we should get an error because that's illegal. Let's give that a shot. Here we are. We see a data record is to be inserted even though a data record with the same primary key or same unique secondary key exists. In this case, it's the same primary key, and all of them have the same primary key of ID 123. We tried to put in ID 123 again, and were rejected. And luckily, it was gracefully handled by our try catch, and we got the information we wanted back from the database. So we have inserted the database, but how do we read from it? So let's read from the database. So we do a simple select statement. We'll write select all, that's the, oh, there we go. Select all, that's the star, and then we'll write from ZTB underscore, let's just grab it. And let's hold it locally. We'll write into table. Remember, we need the escape when we do these sort of statements. So at data, local underscore table. And let's outwrite that. We could see what we just did. Local underscore table. We'll save, activate, and run. And here's our table. We just saw this with the data preview, and now we're seeing it in the console because we selected it and brought it into this class. Let's use this local table to discuss the corresponding operator. We're going to have to make a type here, so we'll write types and begin of. And let's call this SM row for small row. This row will be smaller than the table. It'll still have the ID, type I. It'll still have the country, and that'll be type C, and the length on that was 3, I believe. Yes, it was. But we're also going to have something called new field. We'll make that type C, length 40. Then we'll comma and end of SM underscore row. So that's our small row, and we want to make a table out of that. So let's write data. We'll call it local SM tab. And it'll be type sorted table of SM row, and we'll let it have a unique key since the database already has that unique key. So here's how we select into this smaller table. This table that can't take each of the columns, but wants some of the columns. We'll write select all, and from that table, Then we'll go to the next line and write into, but we'll use the word corresponding fields of. So into the corresponding fields, into the fields that are labeled the same and have the same data type. And we have a few of those. We have the ID type I and the country type C, length 3, which we did check and we know that's correct. The new field won't correspond. Even though type C length 40 does correspond with description, the name doesn't. The name here is new field. So we should get nothing here, and we should get the ID and country populated by this select statement. And remember, we have to do the @ symbol, and then we could write our local SM tab. And we'll outright that. Oh, and make sure we write table right there into corresponding fields of the table local SM tab. So we'll outright now local SM tab here. And we should see our local table get printed first. So that's when we actually have everything from the database coming back and we populate the entire table. And this one is just going to take the corresponding fields and we can see them right after each other. I'll get rid of this with a clear. We'll activate and run. Here we are. We see we have our first one, which brings in everything, and then we have our second table here, our small table, which has our IDs and has our countries, and they're done properly. 1 is FR, 3 is IN, and so on. But since we do have this new field here and it does fit the description, we're going to try to populate that. And in order to do that, we'll use mapping. Let's get rid of what we just did with corresponding. We'll be using corresponding again here, and we'll be using our local table to populate our small table. So we'll grab the small table stuff back. So let's populate this local small tab with the local table. We'll say local small tab equals our keyword corresponding, and then hash. Open up some parentheses. Inside of here, which table are we using to populate our local small table? It's our local table, which has all the fields. It's actually this table, has all the fields. So let's grab local table. And keyword is mapping. We'll write new underscore field is equal to description. So we're telling them that new field is actually the description field. And I wrote descriptions here, so this needs to have an S. There we go. Let's outright this. I'll clear this. We're still going to write the local table, and then you'll see how the corresponding operator functioned. Here we are. So when we said the mapping and we said that the new field is the descriptions, we see that's exactly what happened. The descriptions are now in new field. And we can even use that new field to search. So data, we'll call it found, will equal local SM tab, open up our brackets, right, new underscore field equals, and we'll grab this one, seasoned sausage. Put a period at the end. Let's outright found, and we should see that row. Getting rid of the other outrights. I'll clear the console. And here we are. We were able to find it by the new field. We just interacted with the actual database using ABAP. We still have a lot to do, so let's keep coding. ABAP allows us to run functions as well through function modules, which are inside of function groups. Let's get started on that by making this right-click here. Go to New, Other, ABAP Repository Object, start typing function, and we're looking for function groups. Click that, click Next, And we'll call it z func underscore group underscore 55. Function group lesson. And we'll go to next. Pick our transport and go to finish. Now, we don't want to touch anything in this file. Just go right to the newly created function group here, right-click it, go to New, ABAP Function Module. Now, the first module I will call ZFM for function module, and then we'll just call this samples. This is a very simple one, and we'll call it 55. It's function sample lesson. Hit next. It seems I'm doing something wrong here. I think I need an underscore after the FM. Well, after the Z before the FM. Let's make sure that that's the case. That is it. Okay, and then we should be able to hit finished. A basic function has an importing parameter. Let's call that num underscore 1, type I for integer. And it also has an exporting parameter. We'll call that result, and that's also type I. I have a stray period up here I'll get rid of, and then I'll just do the work right here. We'll set result equal to num underscore 1 times 2, or how about 2 to the second power. Let's save that and activate it. And let's create a class so we can play around with this function. So new ABAP class. Type in ZCL. We'll call this function underscore mods underscore 55. Function module lesson. Let's add in our class run. Hit next. Grab our transport request and hit finished. And we'll call our first function. First, I'm going to create a data object called res for result, type I. We know that's the returning type. Now we use the call function keywords, and then we need the actual function name. I'm going to shorten this up so we could put them both on the screen and see what's going on. Here we are. So here's the function I want to call, single quotes, Z underscore FM underscore SAMP underscore 55. If I want to now use this function, I have to export what it's importing. So I'll write here, export. So we're exporting, and we could use control space to get some finishing for us, get some help. Num1, let's set that equal to 5. And then it needs to import something. So importing, we need the name of the exporting value, which is result. That will equal res. So we'll be holding the result in res, this data that we made just here. And let's just outright this. Save, activate, and run. And we see we get 25. 5 to the second power is 25, so we did call a function. We exported the number that it's importing, and we imported the number that it's exporting, getting the result, which is 25. Functions can also have changing parameters. So I'm going to get rid of this for now, and we'll make another function. So new function module. Let's call this one Z underscore function module, FM underscore change underscore 55, changing lesson. And it needs a function group, which I thought it would put it in there. Oh, I see what I did wrong. We'll do this one more time. We'll cancel out. You should be, instead of clicking function groups, I should be clicking the actual function group I want to use. So let's do that, and we'll grab our module now. Same name, function, module, changing, lesson. Next. And we could just hit finished. Let's have an importing parameter. So we'll say importing, and that'll be num. Actually, there'll be more than one. So I'm going to move this to the next line. Num underscore 1, type I, and then value keyword. We'll explain this in a moment. This will be num2, type I, and you can also make a default here, and the default value could be something like 5 or whatever it might be. Since it's an integer, of course it would have to be an integer. Now I want exporting. We'll call it result again. Type, this will be a string. And then finally, changing. So these are the changing variables. I'm going to call this one ref changed. Let's type ref to I for integer. And this one will be called val changed. Type, and that'll just be integer. Let's quickly talk about that value keyword. I'll do this in a comment. So value allows you direct access to that import, to importing parameters. Let's just write examples of this. What does that mean? So what that means is if num1 comes in, which does not have a value around it, we can't do something like num1 equals 4. This is an error. It won't work. But if we're using value like we are with num2, we can do something like num2 equals, let's say, 7. And this will work. So when we have the value, we can actually reassign the parameter. If we don't bring in the value keyword, we cannot reassign the parameter. We know how exporting works, so we'll do that one first. We'll just set result equal to num underscore 1 plus num underscore 2. But what about changing parameters? So we have gone over the dereferencing operator. We'll take a look at it again right now. So ref underscore change, that's the reference of type integer. What we'll want to do there is point to the dereferencing operator and then set that equal to about ref underscore changed and the dereference plus 10. So whatever we brought in plus 10 is what we'll push back to them. Now val changed will be much easier for us because all we'll have to do is equal val underscore changed plus 10. You could also have plus equal to this to use a little bit less code. We'll have to save this and activate it so we can go ahead and use it in our worksheet. Head back to our worksheet. Actually, let's move this to the right side so we can see both. And we'll head back to our functions worksheet. I'm going to just get rid of everything we did with that first function. And under that, we'll get started. Okay, so function with changing parameters. First, we'll create that reference data that we need. Change me ref. And that'll equal a new integer. And inside there, we'll put the number 3. So this is a reference to a memory space of type integer with number 3. And then we'll do the change me val. So how about data change me val? That's just going to equal 4. It's pretty simple for that one. Next, we're going to need our results, which is our string result in this case. So data, let's call it str underscore res, and we'll give it a type of string. Now we'll use that same pattern where we call a function. So call function, and the name of this function is z underscore fm underscore change underscore 55. We saw last time we export what it imports and we import what it exports, but the changing part is actually always labeled changing. So we'll start with exporting, and we'll do something like num underscore 1 equals 1. And we can have help as well, num2 equals 2, give us some room. And then we have importing. There we'll say result equals str underscore res. So that's where we'll hold the result. And then finally, we'll get to changing. So changing, we'll have the, I will autocomplete this, ref change. So we need the ref, so the change me ref. And we also need the val change, which will equal the change me val. We could put a period and we have everything we need. But we would like to outwrite some of this. So let's do that. Let's outwrite. First thing we'll write is the actually str underscore res. So the result, what's actually being exported from this function and imported back here, the result is first. And then we'll outwrite. Let's do the change me ref, and we'll need to dereference it, even though I think it dereferences it itself in the console. We'll dereference it anyway. Then we'll outwrite change me val. All right, now we have everything we need. We see what's going into the function. We can guess what should be coming out of the function, but let's take a look and see what we get. I'll clear the console, I'll save, and I'll activate. And now we can run. We get 3, 13, 14. Let's see if that's all right. So we're importing two numbers. The numbers we imported were 1 and 2. So the export here got imported here, numbers 1 and numbers 2. And that should come out to 3 when they're added together, so the first one's right. Now we have 13 for the second one, and that's the change me ref, which starts as 3. You'd see it right here. And then we add 10 to it, so it should be 13. And then we have the val change. So that's the change me value. We imported it with 4, we added 10 to it, and we got 14. So everything that we did worked, and we see how changing parameters can be very valuable to us when we're doing functions. I want to make one more function module, so I'll get rid of this one. I'll go to my function group, right-click, new function module. I'm going to name this one ZFM underscore exceptions. Oh, it won't be 1, I'll make this one 55. Function exception lesson. We'll go to next, and we'll hit finished. So we'll have our importing and exporting. Importing. I'm going to do 2, so I'll go to another line. We'll wrap them both in value. Num1. Oh, I didn't write type I. Type I. And then value. Num2. Type I. Exporting will be the result again. And that'll be type I. And then here's the new keyword, it's raising. So we're going to raise an exception if we see X, that's the exceptions class, system, sy, 0, divide, period. And then after this, we can go ahead and write result equals num underscore 1 divided by num underscore 2, period. Let's save this and activate it and put it on the right side of our screen. Get back to our worksheet. Here we are. And I'll get rid of all of this. And what's next? So next will be exceptions. We need a piece of data to return, so data res underscore I, which will be type integer. And we need to wrap this in a try catch so that we can actually catch the error. So we have try, period, and let's get end try in there already. And in the middle, I want to catch. And the thing I want to catch is this error, so I'll just grab it. Copy and paste. So catch this error, and then if we do catch the error, we'll just outright cannot divide by 0. All right, so let's try it out. We want to do a call function. And the function's name is z_fm_exceptions_55. We will export what it's importing. Control and space, num1 will equal 2, and then we have the denominator, that's num2, let's let that equal 0. And finally, we'll import the result. And put a period at the end. Okay, so right now we should run this through and we'll wind up with an error. Let's take a look. We'll activate and we'll run. And we see cannot divide by 0. So when we attempted to divide by 0, it raised this error and it sent it back to us saying we cannot divide by 0. And we handled it with this try catch here. What we just did is raise a runtime exception, but what if we want to avoid the runtime exception and raise it ourselves before it happens? So here's how you do it. If we don't want to divide by 0, we'll say if num_2 equals 0, we can end the if, and then say raise exception type, and then the exception type that we're raising. And right now there won't be much of a difference, so I'll actually change this. So it's just returning num1. There is no divide by 0 here. It'll be us saying that divide by 0 happens here. Make sure that we activate this. We are activated. Let's go ahead and run this. And I'll get rid of what's in the console now, and here we go. And we see it cannot divide by 0, and this isn't the runtime error. This was the raised exception. There's a look at function modules and certain things we could do with them. We'll get a lot deeper into methods as we go over object-oriented programming in ABAP. So let's keep coding. It's officially that time. We're going to start object-oriented programming in ABAP. I'll get rid of this for now. We'll go to classes, right-click, new ABAP class. ZCL_parent class 55. Description, parent class lesson. Add that interface here. Hit next. Choose your transport request and hit finish. And let's get started. So this is a parent class, so the first thing we want to do is get rid of this final. This will be inherited, so this can't be final. We got rid of that. So we have a public section. Public section is available to all instances. In here, we'll define things that are available to all instances, such as methods. Let's do a methods. We'll call it toNumbers. It'll have some importing values, and if you were with me during the function module part, you will be a little more used to this already. And the value keyword will wrap num_1. We'll give it a type of I for integer. And then we'll have another value, which will be num_2. Type integer. Now, we did a lot of exporting when we were doing function modules. Here I'm going to do a returning value. I like it a bit more myself. I came from the world of JavaScript, and it's very comfortable for me to have returning values from these types of methods and functions and so on. And we'll call it result. And type I. We can also set up data, but let's first check this error. It's going to tell us we need to add an implementation, so we'll just add that to get rid of the error for now. And this is the implementation. There's nothing in it. It just made us an empty implementation for the method toNumbers. So back to here, and let's do some data. So this is a regular data declaration here within this class. We'll call it greeting_public. And let's make that the type of string. Give it a value of some sort of greeting. How about, why hello there? And just use the word public so we know where it came from. Why, hello there, public. Now there's another type of data we can do within a class, and it's called class data. Now let's do a greeting underscore public underscore class underscore data. We'll give that a type of string as well, and we'll say the same thing. Why, hello there, public class data. Oh, I'm missing value. Let's just quickly implement this toNumbers, and we'll do it like so. We want to, let's say, return both numbers in one data object. Okay, so to do that, we'll take data numbers underscore combined. Let's set that equal to, we'll put up our pipes, and in there we'll put num1 and one more of the squirrely brackets and num2. There we go. Now, this will technically be a string, but since there's only numbers in it and the type of the returning value is an integer, when we assign it to a result, it will be turned into an integer. So we'll go result equals numbers underscore combined. So let's work within the class for a moment. Within the class, I'm going to activate this. Terrific. Within the class, we can actually call things from the class, such as that toNumbers function. Let's take a look at how that would work. Data, we'll just call it res for result, equals me, that means this class inside of this class, and give ourselves a pointer, and it'll tell us what we can get. We can get the greeting public, we could get the greeting public class data, since we're inside the class, of course we could, and we could get toNumbers. Let's do the toNumbers. So toNumbers is going to take in, control space will let you autofill this. I'm going to go number1 equals 6, and then num2 equals 7. We'll outwrite that, see if it's working properly. So save, activate, and we'll run. 67, that's exactly what we want. We took two numbers and we put them into one data object. I'm going to get rid of everything down here. So what the heck is class data? I want to make a new class so we can interact with this class by instantiating it. So we'll right-click on classes, new ABAP class. We'll type in ZCL. Let's call it classes worksheet 55. Classes worksheet lesson. And we'll add our class run. Next, grab your transport request, click finish. We'll start with some of the basics now. Let's call it class basics. We're going to instantiate that class. So the first thing we'll do is write data. We'll wrap it. Let's call it P for parent underscore CL for class, and then 1. So parent class 1 equals, and then we have to name the class. First we say new, that's the keyword to instantiate the class, so new, and then we say the class's entire name. So it'll be, actually I'll put it on this side so we can see both at all times. Here we are. So it'll be ZCL underscore parent underscore class underscore 55, parentheses, period after it. And there's a few things we can now do with this. We have an instantiation of the ZCL parent class 55. So actually, I'm going to directly outwrite this. So outwrite, and then we'll wrap the code inside. Here's the code I want to wrap. So P underscore CL underscore 1. And now let's use that pointer and see what we have access to. Well, we currently have access to nothing because I have to save this and activate it. Terrific. All right, let's see what we have access to now. Here we go. We have the greeting public. Let's do that first. We should have the greeting class as well, the class data. Let's see. All right, and let's just do those first because it's simple data. I'm activated and we'll run those. Why hello there public, why hello there public class data. Now, class data can be activated without instantiating the class. So I can actually just call the class itself like this. And I'll do this in an outright. So I'm calling the class's name. And then I'm using the equal sign and the arrow. And I have access to the class data. So I didn't need to instantiate this object in order to get this class data, but I did need to instantiate the object to get other things out of this class, such as the data object greeting public, because that's not class data, that's regular data, and that comes with the instantiation of this class. So we're heading right into the class, and we should be able to go ahead and get the greeting public data here. Let's save, activate, and run, and we should get why hello there public data twice in a row. Great. So we'll get rid of everything except for the instantiation of the class. And we'll do just that last part with the methods. So we have a method in that class called toNumbers, and it's returning a value called result. Data, I'm going to call this res. It doesn't have to be labeled result. The returning keyword means whatever comes out of this method is going to wind up in res. So let's let that equal. We'll have p underscore cl underscore 1, and let's point to toNumbers. Now we know toNumbers takes in number 1. That'll be 6. Oh, we did 6 already. Let's do 9 here. And it takes in number 2. We'll make that 3. And we'll outright that. All right, I'll get rid of everything here, and let's see what we got. 93, that's what we expected. This combines both numbers into one data object. All right, we'll get rid of this, and now when I instantiate this object, I actually want to populate some data inside of this class. So let's give that a shot here. We're still going to be in the public section. Let me make sure we have all the room we could possibly have. Okay, so after class data, that's where we'll do some work. So here we're going to say data one more time, and let's do name, type string, and I'll just comment to the next one. We'll call that job, type string, period there. And let's do a method, and this is a special method. So methods constructor. This will have importing values, but no exporting or returns here. So we're going to say importing value. First one will be name, type string. Then we'll have value job, type string. And that'll be it for right now. So what happens in this constructor implementation? First, let's set up the implementation. Add the implementation. Here it is. So the constructor is going to refer to itself as it assigns the values that it was passed in, the name and the job. So it will say me name is equal to the name, and me job is equal to the job. And we should have periods on both of those. And that's a constructor. So now let's save and let's activate this. And we'll save and activate this. But activation fails because now we're going to have to pass something into this parent class that has a constructor. So when it first instantiates, it needs data, control spacebar, and get yourself the name. I'm going to call this shredder, and job. The job will equal fight turtles. Okay, so we have a new class, and I'll bring this to different lines so we can keep seeing everything. All right, terrific. We can kind of see what's going on right there. So now we have a class, and inside of it, it has a data object for name and a data object for job. let's go ahead and access that and outright. So we'll outright p underscore cl underscore 1, and then we'll point to name. And let's do the same with job. Job. Let's do one more so we could see that the data actually lives inside of the instantiation, not inside of the class. So we'll copy this down and we'll make one more. We'll call it 2, p underscore cl underscore 2. And everything else pretty much stays the same, except I'd like to give a new name. How about turtle? And the job is to eat pizza. Let's grab all of this, copy and paste it, and we'll change the name a bit. Okay, so these both have to be 2. And I'll actually bring them right next to each other. Great, that's what I'm looking for. I'll activate that and we'll take a look at how this works. Here we go. So we have the first name, which was Shredder, and he fights turtles. And then we had the second name, which was Turtle, and his job is to eat pizza. But what if the specifications came down and we need this class to follow a singleton pattern? It can only have one instantiation of itself at any time. We'll get rid of all of our outrights, and we'll start working on that. So we're going to be using the private section here. So the private section. This is available only in this class or friend classes. But if it's a child or it's an instantiation of this class, the private section is off limits. You can't touch anything, you can't read from it, you can't write to it without a method that lives inside of this class. I'd like to hold some class data in this private section. So here we are with class data. The class data is going to be called instance count. So instance underscore count, the type will be an integer, the value will be 0 to start with. So this instant count is going to keep track of how many instances are made of this class. And if I want to set a getter so that I can check this instance count from the class at any point, we would do that in the public section. So now we can actually do something interesting. We've done data and class data, and we've done methods. Now we will do class methods. I will call this one get instance count. So this is our getter. It's just going to return the value. I'll label it result, and the type is integer because that's the data it's returning, which is instance count, which is an integer. All right, so let's make our implementation. We'll add the implementation. Here we are. We'll use this to go ahead and reach into the private section and return the instance count by saying result equals instance underscore count. So what does that look like? Make sure you activate. And we'll head over here and let's see what that actually looks like. Oh, we'll bring one of these back. And we could get it this way by going here and getting the instance count. And it is a method, so put up those parentheses. And that will return the instance count. At this point, the instance count should be 2. I also want to show you how we can return the instance count using the parent class. Since it is class data, we actually don't need to instantiate to get this information. So I'll return that one here where the instance count should be 1. All right, we seem to be set up. Let's take a look. We see we have 0 for both of them because the instance count is never updated. So we need to manually update it in the constructor. What I would like to do is add a method called addInstance, and we'll add that to the end of this constructor. So we'll head back into the private section. We'll write methods add_instance, period. And that's all this method needs because it doesn't take anything in. There are no parameters to add instance. We know every time this is instantiated, we're going to add one. So let's go ahead and add the implementation. Instance count plus equals 1. So add 1 to whatever the instance count is every time this is called. And I'll call this in the constructor at the end right here. Add_instance. There we go. We'll save that and activate it and see if our get instances are now working. Save this one and we'll give it a go. There we are. We have instance 1 and 2, and we're getting it two separate ways, one directly from the class and one from the instantiation of the class, this PCL1. But I mentioned we wanted to have a singleton pattern, that we can only have one instance of this. So how do we do that? I want to head back up and see our constructor. So we have our importing values in our constructor, and there's something else I'd like to add to it now. The word is, this is the keyword, raising. Now, this is raising some sort of error. And I'm going to pick an error for us. This is the error class CX ABAP underscore. So CX underscore ABAP underscore auth underscore check underscore exception. There we go. So that is an error class. Now, there's all sorts of different error classes, and we would obviously want to pick an error class that really fits what we're doing. I just took an error class to show how you can raise an error period, and this is the error we'll raise. All right, head back down to constructor, and let's get that logic taken care of. So before we assign anything, before we instantiate anything about this, we're going to set up an if and end if. Okay, so if get instance count is greater than 0, so if it's 1, you could write equal to 1. We want to raise, just quickly make sure we call this, there we go. We want to raise exception, new, and then the exception I wrote in here. Let's grab that. And we have it. So now we do have the singleton pattern set up. This can only have one instance. If it has more than one instance, this exception will be raised. In order to check this out, we need to do a try catch in our worksheet here. So let's set up that try catch. I'll get rid of this in-between stuff here. Okay, and we will try everything in this block. I'll come down here, and we will catch, and then the exception that we want to catch, which is this one. If we find that, and let me do an end try so we don't forget. If we find that exception, we will outright already instantiated. Okay, so save that. Let's activate it and let's run it. We see already instantiated. So what should happen here? Let's grab this one and see what happens with it. If I actually will just leave this one. Okay, and we should see that this comes out to 1. Yes, because we can't get the second one instantiated. The first one was made, it tried to make another one, which caused an error, and we see we only have one class already instantiated. Now we have to talk about child classes, but first let's talk about the one thing we didn't, the protected section. So things that you write in the protected section are available to the children classes, to the child classes of this parent class. In the protected section, This gets passed down to all those inheriting. So the children will get the protected section passed to them. So we'll say accessible to this class and children. I'll call this method, so it'll be methods add _3 _ numbers. We'll do importing and exporting. So first we'll do importing value, and we'll just do num1 type I, and I mean we'll just do num1 because we'll do num2, num3, so we'll copy them down. And we'll export this time. Exporting result. The type will be integer as well. Now we can see that we need to add the implementation. And here it is. Now we'll just add these numbers together and put them in the result. So result equals num_1 plus num_2 plus num_3. And we could try to use this, but it won't work right now. This is not accessible here. If we try to outright, and then we take that same class, you'll see that we actually can't reach this. We can't reach that 3 numbers. That add 3 numbers is not here. So where is it used? In this protected section, why is this important? Where does it go? And that's where we're going to make our child class. So we'll get rid of this. Really all of this. All right, let's head over here to our classes, right-click, new ABAP class. We'll call this ZCL child class 55. And we'll write child class lesson. Let's add our interface. Okay, next. And we can pick our transport request and hit finish. So how do we make this a child class? It's pretty simple here. We just write inheriting from, and then we grab that class. I'm going to get rid of this class run here. It'll give me some warnings, but that's just fine. It'll give me warnings about basically leaving comments in this class, but it should let me do this. Let me see. Nope, I guess it doesn't allow you to just comment it out. All right, we'll get rid of it completely. All right, so that clears our errors. I'm not even sure we'll actually use the class run here because we saw what you could do inside of the class already. We saw how we could access the private and so on. Here we just want to access the protected, the one we just made, the add 3 numbers, which was in the protected section, and do some work on that. Let's do that first. I'm going to head up to my public section. I'll type in methods. And the first method I want to do, add _3 _ numbers _ from _parent. I know that's a long name, but that's exactly what's going to happen. So we were going to take the function that lives inside of that parent in that protected area and use it here. And the cool thing that we'll do, we have this exporting the result. I'm going to be just returning the result instead in this method. So we'll change it just a little bit, but we have access to this one. So let's start doing it. Here we go, importing. So it needs num_1 type I, num_2 type I, and num_3 type I. And then finally returning. Returning value, and let's just call that return _val. Also type I. All right, we've defined it. We need to implement it. Let's get started. We'll need a data object to hold the results. So let's say data res for result, type I. I want to look at me and give us a pointer, and it'll tell us what we can access. We have add 3 numbers. That's in the parent class. That is not this one, add 3 numbers from parent. That's up here. That's what we're implementing, but we do have access to add 3 numbers. So let's grab that, and we'll wrap our exporting and importing. I'll put this on a new line. I'll put a period after and break this up a bit. First, exporting. num1 equals num underscore 1. num2 equals num underscore 2. num3 equals num underscore 3. And then we have to import. So importing the result, and what do we label it? Result. So result equals res. That's what we made just here, and that shouldn't be capital. We haven't been doing it that way. So result equals res. And now in this piece, we have a returning value rather than an export like we do here. So we need to assign something to this returning value, return val. I'll grab that and bring it down. And what we'll assign to it is the res. So we took this method and we changed it a little bit. So instead of exporting, instead of having to do it basically exactly like this, we could do it that other way with the data object in front, like this one, where we just pointed to it and the return populated our data object. So that's a use of the protected section. What else can we do in child classes? Let's do another method. Here we'll do methods, and we'll call this one toNumbers, and then we'll have to say redefinition, because 2 numbers exist here, and our 2 numbers, we're combining the 2 numbers, not adding them. Now we're going to be adding them. So let's do the implementation for that. So here's our toNumbers method. We see that it takes in num1, num2, and returns a result. So let's do that. Result equals num underscore 1 plus num underscore 2. That's as easy as it is to do a redefinition. That method is now changed in this child class. And we'll add just one more piece to this child class before we start using it, the constructor. So go to our public section, let's type in methods, and we'll say constructor. It will be importing value, and let's wrap name. That's type string. We know it from here. We've had our name, and then we have our job, and we know what it's raising. We can actually bring all of these in. But I would like one piece of data to be specific to this subclass, this child class here. So we'll do data, how about subclass name var for variable. And that'll be a type string. So this only lives in the subclass. In our constructor, we want to bring that in too. So I'll copy that, I'll put it in a value. So importing value, subclass name var, type string. Let's implement our constructor. It actually did what we needed it to do for us here, which is terrific. This is a very powerful part of ABAP. It knows what our super constructor is looking for. That's what our parent constructor is looking for. It's looking for a name, and it's looking for a job. And we have one more piece of data, so let's set that as well. We have me, and that piece of data was called subclass name var. We'll grab that, and that'll be set equal to, I think we called it subclass name var as well. Let's see. Yep, okay. Subclass name var. now we have our full child class and we need our worksheet. So I'm going to bring this over to the right again. I'll make one more quick change and go to the constructor of the parent class and make it so that we could have more than one here. We can have two instantiations. And activate that. And might as well activate the child class as well. Let's get this started in the same try. We'll leave the parent class up there. Now I'm going to say data c_cl_1, so child class 1 equals new, and then zcl_child_class_55, and we have to give it everything at once inside of here. Control spacebar, we'll start with the name. Let's make the name Fred. Let's make the job rock mining. And let me make this onto a new line so we can see everything. And finally, we have that extra parameter now, which was subclass name bar. That will be equal to Flintstone. There we go. All right, let's access the data we just put in. So outright, then c_cl_1, get that pointer going, and we can start with name. And we'll do it again. I'll skip the job. I'll just do the subclass name var. And we have to actually end this try, so we'll leave the catch in and end the try like so. Terrific. Okay, now we can activate and we should be okay. We are. Let's see what we get. Fred and Flintstone. Those are the two things that we put in for the name and then the subclass name var. Let's try our add 3 from parent. So I'll say data res I, it's going to be an integer, is equal to, and then c_cl_1, add, I'm not getting my autocomplete here, there we go, add 3 from parent, and we'll put in everything in here. So control space, num1 equals 1, num2 I'm going to set to 2, and then num3 I'm going to set to 3. And let's outright. res_I. I'll get rid of these other outrights and I'll clear the console. Oh, you can see I put the period in the wrong spot. There we go. And we're activated. Let's see what we get. We get 6. 3, 4, 5, 6. That worked. And we know one of the cool parts of this is we were able to change it from what it was doing with exporting, importing, to going ahead and returning a value. So we could do it this way. And we have one more. It's our redefinition. So I'll get rid of this for now. We redefined 2 numbers, so I'd like to outright it twice. So we'll outright this, and I'll have another outright here. The first one will be from the parent. So we have our PCL1, that's our parent class one. Let's grab that, and we'll point to 2 numbers. And then we'll give it its 2 numbers. Num1 equals 7. Num2 will equal 11. Okay. But we also want our child class, because we did a redefinition here, and it should be quite different. So we'll go with the 2 numbers, and it has everything the same here. I'll just copy it down. And this parent class combines the 2 numbers. This should be 711. And the child class adds the 2 numbers. This should be 18. Let's take a look. There we are, 7, 1, 1, and 18. That's how the redefinition works. Let's go over narrow casting, because it has something to do with our redefinitions, and it could be a gotcha if you don't know what it is. So narrow casting right here. Just remember that all child classes are instances of parent class. So you could use a predicate function to find that, and we'll do that right now actually. Let's do that now. So data, let's call it P underscore CL underscore 3, so parent class 3, and I'll get rid of this one so we don't run into errors. There we go. So parent class 3, type is a ref2, so a reference to the parent class. So there we'll write ZCL underscore, actually I'll just grab it, and put a period after. Now we're going to check what we just wrote here. All child classes are instances of the parent class. So we'll outright, and we could use that XSD bool, wrap this in that. So C underscore CL underscore 1, the child class, is instance of, and I'll throw the parent class there. So we're asking, is this instantiation of a child class an instance of the parent class? Let's see what they tell us. And we get X, which is ABAP true, so we know that all child classes are instances of the parent class. So I'm going to narrow cast this child class into our reference to the parent class that we have here. Let's get that done. Just set them equal to each other, and that's that. Now you'll see that only data that's in the parent class is accessible. We have our greetings. We don't have our other ones, like add 3 numbers from parent. It does not exist in here because it doesn't exist in that parent class. And we narrow casted it to have just what's in that parent class. But there is a big gotcha here. Redefined methods continue to be redefined. We know the parent class, when we have this toNumbers method, when we give it 2 numbers, it returns them one after the other. And in that child class, it was being added together. Here I'll show you that it will be added together. So redefined methods, when they are narrowcast like this, stay redefined. num1 equals, we'll go 4. And then num2 equals 2. So the parent class would make this 42. The child class would add this together to be 6. And we should be getting 6. But it would help a lot if I outright this. So let's do that real quick. Can't wind up on the screen otherwise. Here we are. We'll activate now. I should get the X. You know what? We'll get rid of that one too, and we'll just outright what we want to outright here. There we go, 6. I know it seems like we've been through a lot of ABAP, but we're not done yet. So let's keep coding. It's time to talk about interfaces. We're going to make an interface, so go up to your project and right-click it. New, and then ABAP interface. If you don't see it here, you could go to other ABAP repository objects and type in interface, and you'll find the ABAP interface. So this one we will call Z underscore IF underscore add underscore 55. Interface lesson. And yeah, we don't need to add anything to this one. We'll just go right to the next, and we'll grab our transport request and click finished. Let's clean things up a bit. I don't need this anymore, or this, and I do need you, but we'll get rid of some of these. Great, I cleaned up a little, and you could see this gave us a new folder. It says interfaces here, and that's where this lives. An interface is a place where we can do definitions without adding their implementations. So we'll do methods, and we'll have add underscore to. We'll import, so importing value n1 type I, and then we'll have value n2 type I, and then it'll be returning value, and we'll call that sum type I, period. And let's do one more so we could get a little bit of practice, and we'll make this a simple one. We'll do add 3. So we'll have the same thing going on here. But we have to import one more. Value n3 type I. That's it. That's our entire interface. We could save that and activate it. I'm going to bring our interface to the right side of the screen. And we will be using our worksheet, not right at this moment, but I'll leave that up. We need one class to go ahead and implement this interface. So let's make that class. We'll click classes, right click it, new ABAP class. We'll name it ZCL underscore interface underscore 55. And then interface lesson. We won't add in any interfaces to this. We don't need them. So here we are. Okay, and we can finish. Now I want to consume the interface I just created, and the only place you could do that is in the public section. So make note of that. When you have interfaces, declare them in the public section here. I'll call it Z underscore IF underscore add underscore 55. So here's an interface that we'll be using. And you can see right now it gives us this here to the left, add to unimplemented methods. So we'll click that. And here's the implementation that we'll do for this interface. And remember that the interface is reusable, so I could reuse this in a different class if I wanted to. But let's get it started right here. We'll do add to first to put us a little out of order there. And then real quick, it's just sum equals n1 plus n2, that's that one, and this one will just be sum equals n1 plus n2 plus n3, and we've implemented this interface. Now we will activate, and we are activated. Let's go back to our classes worksheet, and we'll pull from ZCL interface 55 here. Okay. So we'll write data, and let's call it interface underscore class. That's going to equal new is the keyword, and then the name of the class, and then we have to instantiate. Here we are. And we should have access to its methods. So let's outright and use both of its methods. So let's write that interface class, and let's point. Going to point to the interface, and next we need to do the tilde. So that's our next move, and then we could access add to and add 3. So remember that tilde. Whenever you're using interfaces, you have to use the tilde to get to the methods. So here we are with add to, and we'll fill that out real quick. num1 will equal 1, and then num2 will equal 2. And let's do this one more time with 3. Interface underscore class. We'll point to the interface, and then we'll tilde to add 3, and then we'll put 3 different ones inside of here. I'll put it on a different line so it all stays on the page. Actually, we could just increase this as well. Okay, so n1 equals 1. n2, let's make that equal 2, and then finally n3 will equal 3. Let's clean this up a little bit. Shift F1 will clean you a little bit. And then let's activate. We are activated. I'll clear the console, and then we will run. I still have something going that gives us that first 6. Let me get rid of that. We don't want to see that. Here, this outright. Okay, we did get the right answers, but I'm going to clear and just do that one more time. All right, our first one was 1 plus 2, which is 3. Our second one was 1 plus 2 plus 3, which is 6. And that's how we use interfaces. Right when I finished the video, I thought I should mention the tilde in the class as well. Just take a quick look at that. Anytime we're using an interface here, we're still using this tilde. So just be very conscious if you're using an interface, you use the tilde to get to any of its methods and so on. Stick with me, we just have a little more to do. Let's keep coding. Abstract classes are very similar to interfaces, but they're written in a class structure rather than this interface structure like this. I'm going to get rid of this interface here. And we will go to classes. We'll right-click, new ABAP class. Let's call this one ZCL abstract class. And then underscore 55. Abstract class lesson. We don't need any interfaces for this. Go to next, and then pick your transport request and click finish. Much like an interface, we only have to define the methods here. We don't have to actually implement them. First thing we'll do is this says definition. We have to add abstract because this is an abstract class. And then final, we're not going to be final on any abstract classes because they must be inherited. If they aren't inherited, there will never be an implementation for any of the definitions. So in the public section here, let's go ahead and define a method. So methods. Let's call it say my name. That'll be the method. Label it abstract right now, so right there. And now we could do our importing and exporting. We'll do importing and returning, as I really prefer that. So importing will be the name, type will be a string, and then we'll have the returning the value result. And the type is a string. So that's it. We set up an abstract class. It's ready to go. Let's create a class that will inherit from our abstract class by going to new ABAP class, ZCL underscore abstract inherit underscore 55. Inherit class lesson. And on this one, yeah, let's just add that outright. So this is a pretty simple one here. We'll finish up. Now we have to say inheriting from, so let's do that. Inheriting from, and that was this guy. I'll move him to this side of the screen. And we'll write it out. ZCL underscore abstract underscore class underscore 55. Make that a bit bigger, and we can see we have issues right away. What does it say? Add implementation for say my name. Let's do that, and we have a method called say my name. We know what it is taking right here. It's taking a name and it's spitting out a result. So what do we want to do with this? Let's say result equals, and we'll put up our pipes, hi. Your name is, and then the name that was given, and a few exclamation points because we're so happy about knowing that person's name. So we'll save that, and I'm just going to call it from this class run main so we could see it print out. We'll out, write, say my name, and in there we can put name equal to Papa. Okay. Now we'll save. Let's activate and let's press run. Hi, your name is Papa. So we just took an abstract class, we inherited from it, and we implemented the method from that abstract class. I had a terrific time going through the ABAP language. I think it's incredibly powerful, and we haven't really even gotten past the surface of the language. There's so much you could do with it. There are so many tools. There are so many ways to build on top of ABAP, and I'm really looking forward to you showing you more. Thanks for being here with me through these videos, and keep coding.